In this video, we will model stock return using normal random variable and demonstrate the importance of distribution in identifying financial risk. Why it is important to know the distribution or model for stock return? It is really crucial in risk management. For example, the stock price of Apple dropped over 40% from August 2012 to May 2013, roughly 1 year. We need to compute what the chance that the yearly return can be less than negative 40%. Is that possible or just extreme case, like black swan? We compute log daily return for stock price of Apple. The histogram of return is symmetric and bear-shaped, which is very similar to normal distribution. Using scipy, which is a scientific computation package of Python, we can get density function and a cumulative distribution function. nom.pdf will get density for each possible value of a normal random variable. In fact, normal random variable can take values from positive infinity to negative infinity. In Python code here, we get density between negative 4 and 4 for simplicity. Two parameters 0, 1 in nom.pdf gives the mean and standard deviation of a normal random variable. This normal random variable is also called standard normal random variable, and its distribution is also called z distribution. You can change these two values in order to get different normal variables. Because the density functions of normal variables are only related to their mean and variance, we also can get a cumulative distribution function, or in short CDF, which outputs the probability for the area on the lower side of each possible value. On the left side of this slide, it is the graph for normal density, symmetric with a mean and symmetric center. It is also bear-shaped. On the right side, that is cumulative distribution function. When x take larger values, the cumulative probability will approach 1. We can model daily stock return using normal distribution. We do not know the real mean and standard deviation of this normal random variable. We have a large collection of daily return from historic data. We can compute the mean and standard deviation in this collection. They are not the same as those of normal variable, but close enough, as is shown on the right. Then, what is the chance daily loss can be more than 5%? First, we will plot the normal density curve for this daily return. This pink area is the probability of losing more than 5% in 1 day. We can use CDF to get this probability, which is 0.5%. Hence, we have 0.5% chance to have a daily loss more than 5%. Our goal is to find out how likely that the stock price of Apple will drop over 40% 1 year, which has 220 trading days. We will use another normal distribution to model yearly return. We need to figure out the mean and standard deviation of a yearly return. We make assumption that the daily returns are independent, which is quite strong, but it can simplify our discussion here. To get the mean and variance of yearly return, we have formulas for sum of variables. We need independence when we compute the variance. If the daily return is independent, the variance of a yearly return is equal to the sum of variance of 220 daily return. Again, with no CDF, we compute the probability and it is less than 2%. That implies there's only less than 2% chance to have yearly loss to be more than 40%. What happened to Apple in 2012 and 2013 is not consistent with its overall performance. In many circumstances, we need to solve a different type problem with distribution. For example, finding quantiles of the normal distribution is a common task when performing statistical tests and financial risk management. Normal distribution quantiles can be obtained using norm.ppf. ppf stands for percent point function. In finance, related to quantile, there's an important risk measure, value at risk, or VAR. It estimates how much a set of investment might lose with a given probability. VAR is typically used by firms and regulators in the financial industry to gauge the amount of assets needed to cover possible loss. For example, 5% quantile of daily return is called a 95% VAR, or VAR at the level of 95%. We can use the PPF to get 5% quantile, which is negative 0.03. Hence, 95% VAR is negative 0.03. It means with a 5% chance, the daily return is worse than negative 3%. Is it safe to use normal distribution to model stock return? Two famous professors in the field of asset pricing, Farmer and French, responded in this way. Distribution of daily and monthly stock return are rather symmetric about their means, but the tails are fatter, which means there are more outliers than would be expected with normal distributions. It means that extreme returns, negative as well as positive, may occur more often than we expect if we use normal distribution. This conclusion is debatable, at least for the returns of some assets with different time window size. To model fat tail, people propose to model return using t-distribution with low degree of freedom. We will discuss and use t-distribution in the next several topics.